extended temperature range, but also with the same AI engines inside with low power. And this is exactly what we need, because everybody can run a local large language model on a monster x86 CPU with hundreds of watts of power. So this is today is possible, but this is of course not the way that industrial edge devices should run.
Okay.
And to clear here on the sustainability side.
Welcome to Avnet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Haydock. The AI landscape has rapidly evolved over the last few years, from the hype surrounding large-scale machine learning models to practical application in industries like automotive, manufacturing, and beyond. But now the question is, how can the sector harness the power of generative AI to run efficiently on local devices rather than rely solely on the cloud? My guest today is Martin Grossen, lead solutions and software at Avnet Silica, and he will share with us his insights on this shift. Together, we'll explore how localized AI models can be used in industrial applications, and we'll talk about the challenges the industry faces. We'll also discuss ethics, risks, and costs deploying AI in industrial environments. So welcome to the show, Martin. I'm really happy to have you here. Tell us a little bit about yourself and what it is you do at Avnet Silica.
Thank you, Ruth, for the invitation to this podcast. So my name is Martin Grossen. I'm the Director of Solutions and Software at Avnet Silica. I'm based in Switzerland, but I'm sure you could tell this from my accent, oder? I'm responsible for the whole connectivity and cloud, also licensing the suppliers, all the OEM software stuff. So yeah, a broad range of products and services.
So tell me, is the AI hype over?
No, just in fact, when we see the hype curve from Gartner, the AI, and of course we have different AIs we have to talk about. But the generative AI we want to talk about is just in this hype curve on top. It will fall down and then hopefully going up again to reach the platform of the industrialization. And I think we should really step back a little bit to get an overview also what this generative AI on industrial devices, what are the needs and what we need to achieve the integration of this technology. Because we are in the middle of the fourth industrial revolution today. You know this as Industrial 4.0. This phase is characterized by the integration of technologies such as IoT, Internet of Things, the artificial intelligence, machine learning, and big data analytics into industrial processes. Now, IoT, the Internet of Things, as the term specifies internet, you need some kind of connectivity, of course. If this is wired or 4G, 5G, NB-IoT, LoRaWAN, Sigfox, or local infrastructures, Wi-Fi, sub-gigahertz, you name it. So a lot of IoT devices today and a lot of sensors are all already online, but they are not really smart.
Okay.
They only submit some kind of telemetry data, for example, temperature or pressure, or really simple data. The market just started to implement now and connect smart IoT devices. And of course, a lot more to come in the future. From this big data side, we not even scratched the surface today.
Interesting. My initial question, of course, was a little bit provocative, but we've talked about this before when we prepared the podcast. Of course, the question is much more complicated because AI has been so much in the spotlight over the last couple of years, and now everybody is talking about the bubble that has burst. But I think it's really interesting that you say, but we have really just scratched the surface, and it is what it is with most hypes. There's the famous Gartner hype cycle where after exaggerated expectations, there comes reality, and then, right, you go back up and find more solutions again.
Absolutely. For technologies like vision, or this the standard pattern vision detection, or this kind. This is already in this productivity platform phase. So companies are really making money out of it.
Okay.
Here with the generative AI, everybody's in this hype phase, but on the industrial side, there is no real big companies that are making money out of them. The ideas are there. Of course, we're on the hype phase, but the real implementation, a standardization, a industrialization, we do not see at the moment. And this will take time.
Can you explain what running generative AI models on industrial devices actually means?
Yes. So the problem with generative AI is you need a large language model somewhere stored and accessible. When we see all the tools today on the internet, then of course you connect to some kind of database online on the internet to do the calculations, to let this large language model LLM do his job. And here, of course, with industrial edge devices, we need a stable internet connection to do that. And sometimes we cannot rely on a stable connections in the field. So we need to run these LLMs, these large language models, locally on the device. And now here we have a problem. The problem is, to do that, we need, of course, a lot of CPU power, performance. But we are on the edge device side. You need a low power device. So you do not have the power, but you need performance. And you need a dedicated AI engine to do that from the performance wise, to do that efficiently. So this gives us on the semiconductor side a clear must-have checklist that we need to have to do that industrial generative AI local devices. And we do not have this kind of semiconductors right now. We are on the good path to have them. Of course, low power means we talk about low power CPU, NPUs, even ARM technology, not x86 technology. So why the x86 technology cannot scale down? They can scale up on the power side. They have a problem with low power connectivity stuff. On the ARM side, they can scale up on the performance, even with low power. So this is why the ARM technology at the moment is really the technology to go for, also especially for the AI side. The mobile phone technology is clearly showing us that. So on the mobile phone, there are only ARM processors and they have really powerful AI engines inside. But these consumer products we cannot use on the industrial side. You need industrial semiconductors to drive this business. You need extended temperature ranges. You need reliable technology. And this is not the consumer versions. So you cannot go with the latest, greatest 4 nanometers production technology for industrial devices. That's why industrial devices are always several years behind the consumer specs.
Interesting.
And this is exactly what we see now. The first devices are now getting available from the suppliers. See, for example, Qualcomm was very successful on the mobile phone side. Now they decided to introduce a real industrial roadmap as well with their products. With all the technologies, as I said, with extended temperature range, but also with the same AI engines inside with low power. And this is exactly what we need, because everybody can run a local large language model on a monster x86 CPU with 100 of watts of power. So this is today is possible, but this is of course not the way that industrial edge devices should run.
Okay.
And to clear here on the sustainability side, we need low power because we talk about millions, billions of edge devices. So the only way and the key is sustainable, power efficient device. Anything other will not work.
Okay. And what types of industrial applications are we talking about? Who would benefit most from these localized AI solutions? Can you share some examples?
Not that easy because, of course, we have on this industrial edge devices, we talk about a really broad range of devices and markets.
Okay.
We have smart cities, we have medical, we have POS, so point of sales, retail. Of course, industrial automation overall is the biggest part, but this is also, everything is inside there. So, and in every scenario, you can think about the usage of this generative AI functionality. Means that you do locally decisions with the data, with the input you have to do a better job, to make a decision, even a predictive decision, a preemptive decision. And I think most common will be the industrial devices that have a user interface. So that means we can use then our spoken language, voice, to steer the devices. So we will see that more and more in different languages with different slangs that the AI will understand. So especially on the user interface side, we will see a lot of changes with the AI, local. And you need it locally because else it will not work. You need a local solution for that.
But I imagine that you need a lot of data, as you have mentioned, to run these language models. How does that then actually work?
This is a very good but a very complex question, of course. When we see the large language models, GPT-3, for example, we talk about 175 billions of parameters stored in a database. Nothing that we can run locally on a small device. Also from the memory size, this is not possible. And let me explain how an AI engine works in a simplified way. These parameters are internal variables of a machine learning model that are learned from the training data and then stored in a vector database. Of course, this vector database needs then to be local available on a device. With this vector database, think about a three-dimensional space like a cube. And in this space, the parameters are stored with exact room coordinates, X, Y, Z. And with a 0 point in the middle of the cube. So then the parameters, the words, like an apple, is stored in this space, and this is very closely stored to the word, for example, banana, or beer, or whatever else. So, and in a different space, the word dog is stored close to the word cat. And also when you have different stuff, then it's really in the opposite. So opposite meanings are stored in opposite space. Now to get an answer, the AI engine divides your input into tokens. That can be words or even fraction of words. And it's searching a path or a vector through this space. This is a purely geometrical mathematical calculation and with some statistical branches. Okay, an AI model is using vector database with several hundred dimensions. So not that easy, but this is the way that really an AI engine works. That gives you a basic understanding what the generative AI engine is doing. Now this database, back to these parameters. With GPT-3, we had this 175 billion parameters. And these large language models we are using day by day are going bigger and bigger. ChatGPT-4 has several trillions of parameters.
Wow.
With a MOE, a mixture of expert model. It's also very interesting because the mixture of expert is a machine learning approach that divides a model into several subnetwork experts. For example, NLP, natural language processing, to understand our language. This is a separate sub-expert language model inside. Now, we need to bring these LLMs down for a localized usage. And this is exactly what's happened right now. There are more and more open source, smaller, optimized LLMs available. Because we need, of course, for special things that these industrial devices are doing, these are dedicated usage devices. We need only a dedicated language model. We don't need the full-blown LLM. This is exactly what we see at the moment. With LLMs like Llama, Bloom, Bird, Falcon, Mistral, OPT, XGen, Neonix, there are tons of these. We have smaller possibilities to do local languages on the local base. Microsoft also just released with Phi some smaller open source LLMs in 20 languages, for example, and with 16 smaller models inside. You can choose. So you can do like a Lego system. You can put your bricks together. Say, okay, I need language. I need speech to text, text to speech. I want to interact. I have a user interface and I want to do pattern recognition or this and that. So then you can mix your smaller models that it fits your needs. And this is exactly what happened. But there is no standardization right now. Models are visible now from various suppliers, and we do not know what quality is behind, what was the training data behind. It's a lot of unsecurity as well, of course, in that. But this is the way to have a localized version of generative AI.
So that seems there are still a lot of challenges ahead. And when you mention things like quality, my mind, of course, already jumps to, but then is that safe?
Yeah, that's a very important point. Because when we talk about connected devices, we always have to talk and think about cybersecurity and cyber resilience as well. Especially in Europe with the upcoming CRA, the Cyber Resilient Act. Even if we are still in the legislation phase, the 24 and 36 months of implementation phase will start soon and latest in 2027. Every industrial device in Europe has to follow the norms. Of course, this is a very hot topic at the moment, and I'm sure you will have multiple episodes in this podcast about cyber resilient and CRA very soon.
Yeah, we did have I can maybe link it in the show notes. We did have an episode also with a colleague of yours and a partner from Avnet Silica talking about the CRA and the also opportunities it will bring. And of course, making it safer, especially when, the thing is not completely developed and nobody knows yet how they will use it and how it's possible to achieve these things with large language models. But then obviously they must not be biased. The data must be, I guess, of very high quality. And then, you have to be assured that the training has been done by someone who also has knowledge of your industry, right?
Absolutely. And this circles back to your question about the scenarios for these devices. Because, yes, this generative AI will allow to drive predictive scenario. And there's always some kind of interaction. Sometimes, of course, there are devices that have no interaction, user interactions. So with this local data that they gather, and of course the sensors are going better and better as well. Let's have a look at, for example, smart city. A sensor in a light pole, for example, can really gather everything like air pressure, temperature, sunlight. Even they can count the cars below and so on. So they can check the park lots. And so there's a lot of data coming in, amount of rainfall and so on. So also a lot of environmental data that these devices will scatter. So it makes no sense to submit every second all this data to a centralized server. This is what happens today. These IoT devices send the data every minute or whatever, or even all 5 seconds as telemetry data to a cloud database. So what to do with this data? Of course, you can do in the cloud, you can do then a lot, but sometimes, and in a lot of industrial solutions, you have to steer something. So it's not only sensor, you have actors as well. And you want to steer these actors in a smart way. So you have to do the prediction on the device level because you don't want to be dependent on a stable internet connection. You don't want to make the decision on the data center side. You want to do the decision on the device side. Then, of course, submit everything that is relevant. So also this data filtering on the edge side is very important. That's why I'm talking about smart edge devices, not the non-smart ones that submit everything. So data filtering, predictive decisions, and of course, exactly on this scenario that you want to have. Other scenarios are a little bit more difficult, like when you have an interaction and a user interface. Then, of course, you will have a lot of different scenarios you have to run through. With normal way of programming, you have no chance to do that. With generative AI, you definitely have a chance. And we have seen, we got a lot of customer requests right now from customers that say, okay, now we want to start with a human interface for our industrial devices. Mm-hmm. So this is the biggest opportunity that we see in generative AI.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by Avnet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. So one of the key decisions companies are now facing is whether to run the AI on the edge or keep relying on the cloud. How would you make that decision if you were the responsible industrial company?
Sometimes you don't need to do this decision because you can also run a hybrid solution.
Mm-hmm.
So you can have a local running LLM, a very small one, a very performant one, low power, and then when the LLM says, okay, I do not have a solution for that question or for this problem, then I will contact the data center. This is, by the way, on the consumer side, this is already implemented. Microsoft just released the new Copilot PC. Maybe you heard about that. Mm-hmm. This is a laptop where a huge LLM is stored already on the hard drive as part of the operating system. So when you do your daily job with Copilot asked questions, then the response will be very fast, much faster. When this engine do not have the answer or do not get an answer, they will connect then online to the big GPT-4 AI and then get the answer in and also help to train the local model. Mm-hmm. So this is exactly the way that also on the consumer side they implement that. And we will see the same thing on the industrial, but of course more dedicated to the usage of this device.
Interesting. Yeah, that's my dream, that the laptop does the work for me, right?
Exactly. We're all waiting for this for years.
Yeah.
Exactly. No waiting times anymore or faster way to work. Yeah, absolutely.
Yeah. You mentioned that implementing this technology is still quite expensive. Do you see that changing soon?
It must change, else we cannot implement it. Mm-hmm. As I told you, this first silicon semiconductors that we just see from these companies, of course they are new, they are still expensive, but the price will drop down, the performance will go up, power consumption will go down, or to the power to the performance ratio will get better. And this is exactly what we need. The price needs to go down. Else, of course, we have a problem with the implementation. Then only some high value OEM manufacturers on industrial can do this. And this is also what we see, of course. Not the small sensor customers will start with this implementation. It will be the high range of devices, industrial devices, the big machines with really nice performance CPUs inside. They will start to implement that. And then everybody wants to have that, of course. Then it's a marketing thing only. And when you can interact, this is, I think, we dreamed of that for a long time, that we can interact with these industrial devices a very native way, mm-hmm. with voice and also really with different languages. We're not dependent on really using then a keyboard or a mouse or anything like that. So we are not that far away to get a real implementation on that side with generative AI.
I imagine that would also make it easier to train people to use these machines, right?
Absolutely. This is another topic, how to train these models. In the early days, the early models, the companies that invented these models or trained these vector databases, they really checked the input. They really filtered that stuff. They checked it. There was a very high quality. But with this massive, this huge parameter number, as I told you, with trillions of parameters. No way to check now the trained data. And of course, for example, the Google AI used a Google database to train the AI. So a database they already had. The problem is then to differentiate what is fake and what is not fake, what is real. And this is the problem, because such a training data can sometimes not, or training engine cannot differentiate if this is now, was this fake information or was this a joke somebody did? So there are several of such funny answers from the AI engines in the internet. So, for example, when you asked the Google AI how many stones that you have to eat per day, the answer was 2 to 3 stones you have to eat per day. Because somebody thought this is a joke. Yeah, they say, okay, I have this data in my database, I will use it. So the quality of the database is really key. Also how it's going forward. And as I said, we talk about geometrical mathematical database at the moment. This is not really smart. In fact, it's not intelligent. Even if we call it the AI, the artificial intelligence, but it's not intelligent, especially when we talk about these tokens that are so small, like a word or a fraction of a word. In our brain, the human brain, we can see the full context. But the AI engines do not see that. That's also why sometimes the output is incredibly wrong or close to wrong. So and a lot of people tell me, hey, when we create text out of ChatGPT, I will see if this comes from ChatGPT or from a human. I can see the difference. I can feel the difference. This is exactly the point. Of course, this is going better and better from these engines as well. So we see a lot of invention there and a lot of change, but it's not really smart at the moment.
It's interesting. I saw an example somewhere on a forum where they were discussing why the GPTs are not able to tell how many R's there are in the word strawberry. It would always say 2. It would never say 3. And then one, I think, IT scientist explained why the language model is not able to count the R's in the word because of how the engine actually works, right? Exactly.
It's exactly because of this path, especially when you have 2 R's side by side. So they have exactly this problem. But this is this exact speciality. When you have an industrial device with special requirements for a special topic, then you need to be sure that this model you use and you train, maybe you trained or you're using an already trained model that is really suitable for this solution, and this gives you the right output. Why? Sometimes we do not have humans behind the outcomes here in industrial devices. We have some actors that are doing things. So opening some water valves. So you don't want to have an open water valve when you don't want to have it. So maybe then the decision to do that needs to be very, very accurate. This is why you need good quality trained models for that, not some consumer models that are trained from sources that you do not know. This is, of course, a risk as well on this side.
Absolutely, and which brings us back to the security and also the ethical implications of this, because also AI models tend to inherit the biases that come with the data or the person who trained the model, right? With unwillingly, obviously, and sometimes the bias only shows itself after the model has been trained, and then you look at the outcome and then you realize, wait a minute, why would you come to a decision like this? This is not what I tried to train you, but obviously the data was biased and I didn't even know about it, right? So it's in industrial applications, I imagine there has to be so many more security layers testing this. And even during the process of the application that is then running, you still need lots of layers of security, I guess.
Absolutely. And we will see also some clear restrictions on or regulations now coming up here. We have this AI Act in the EU that will come up. Also then really securing for, as example, life-dependent systems that, of course, you're not allowed to this, or you have some more security layers on it. So, of course, you always need to think about the risks behind that. So, and there are absolutely regulations now showing up to do that, to get rid of companies to say, yeah, okay, let's try it and let's sell it, and when something happened, okay, we are bankrupt, but then you have a massive problem, or maybe in a smart city or wherever you use this system. Huh?
Mm-hmm. So, and as AI continues to evolve, what trends do you foresee in the industrial sector? Are there any things you are excited about? Anything that is on the horizon that we will hear more about?
Absolutely. And we see that at the moment on the hardware side, on the platform side. We see a massive shift from this x86 world to the ARM world. As I said, from performance and power side. So ARM, this is, of course, the high-end sector, because the low-end sector, the really low power and low performance, they were already on ARM for a long, long, long time. But now also this high-end sector. And sometimes this is the trend to see, okay, I will combine a lot of functionalities in one node, in one edge device, and then I can use a high-performance system, then also with AI, and then do a much better job than 100 smaller devices, like a concentrator in the field. So, and this is where I see the biggest change at the moment, that customers think about, okay, let's step away from this high power engines, industrial PC side to really small factor, low power ARM side. And even Microsoft really saw that, and on the software side, they're following exactly this path. This new ARM-based Qualcomm that I talked about will be supported by a full-blown Windows IoT enterprise for ARM from Microsoft. And even existing x86 or PC code and application will run emulated on ARM. So Microsoft is already ready for this transition. And we see that also on the data center side. Everybody's throwing out their x86 system now to replace them by ARM. Even some data center suppliers now made their own ARM chips with 128 ARM cores inside to drive this AI engine on the data center side. So it's unbelievable move right now on this side. So a lot of customers will need to will redesign their systems. And this is also the biggest challenge at the moment. Then to, for example, fulfill the Cyber Resilient Act together, because every platform will be connected. There's no new platform anymore without any connectivity. You cannot. There's no one that doing this, or this platform is available. So here we really see a big shift on this side.
Again, what would your recommendation be to these customers? How should they start?
So here there's no one-fits-all answer, because it depends on what sector they are, what verticals they want to do, exactly what interfaces they have. They want to have, is it user interface or not? Is it only steering? Is it only a data sensor side? So it really depends. And this is the big problem. Not one fits all answer. So we need to dive into the solutions case by case.
Okay.
This is also why we now invested a lot of money, for example, as a company, Avnet, to exactly build up a team to help customers to find the right solution. Because we do not talk only about AI or hardware or software, operating systems and cybersecurity and on. We talk about one solution that inherits everything here. And this is the big problem, because not every customer do have the right know-how to think about everything here, to do such a new design. The past, it was pretty easy. They bought the industrial PC. It's a PC. Everybody were able to program it, then put an application on top, sell it as a solution. That was it. This time will be over, especially when we talk about Cyber Resilient Act. Then they have to think about, okay, what's about maintaining, updating, security implementation, and so on. Then also with AI, exactly the same. So it's really, this world is going more and more complex.
Yeah, thank you, Martin. This has been very, very insightful. And what do you think? When should we talk again? When will we see the next innovation shift that should let us meet again?
So on the AI side, we see a lot of activities right now. I'm really more than happy to talk with you about solutions when we see the real implemented solutions in the industrial world that are really working and a big one. So this, for the early adapters, this will be in the next half year, definitely. They will adapt this.
Cool.
And for the big market, of course, later. But this is definitely the time frame that we see the implementation. Also from the hardware side and the possibilities. Not cheap solutions, of course, but first implementations. We talked then about success stories, hopefully, as well.
Sounds great. It's a date.
Good.
Cool. Thank you so much, Martin, for being on the show.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.